Welcome to the channel.
Here, we have to find out the type of circuit: operational amplifier, inverting terminal, non-inverting terminal. Input is applied at non-inverting terminal. This is feedback in between diode, output capacitor. This is output voltage. Say diode D. We know that this is anode of diode, this is cathode of diode. If input is positive at the anode, the diode will be forward biasing. If reverse polarity, having to say the negative supply at anode, the diode will be reverse biasing, diode will be off state. In previous videos, I explained the working of diode. I am providing the link in the description box. We know that here in the operational amplifier, if you are applying the input at inverting terminal, so output of op-amp will be positive if input is positive, and if this positive voltage is applied to the anode of the diode will goes into the conduction state. Diode will be in forward biasing, and simultaneously capacitors start charging, and we are getting the output voltage. If I am applying the sinusoidal signal at inverting terminal, so during positive half cycle, the output of op-amp is positive, and positive is connected to anode of diode. Diode will be in forward biasing, conducting. And this is like a buffer. So whatever the input we are applying, we are getting at the output. So output is equal to input. And capacitor starts charging, say C capacitor. And here we are getting the positive half cycle, like an input at the output side. What will happen during negative half cycle? If the input is negative and we are applying at non-inverting terminal, the output of the op-amp will be negative. If the input is negative at inverting terminal, output op-amp is negative, and negative voltage is at the anode of diode, reverse polarity. So diode will be in off state, and there is no current conduction through this. But there is no conduction since the diode is in off state. So output voltage will be 0 in this case. There is no discharge path for the capacitor at the output side. Diode is in off state since op-amp output is negative, and there is no conduction of the current, and output voltage will be 0. So in this case, there is no output voltage during negative half cycle, and therefore what output we are expecting for sinusoidal input, we are getting output during positive half cycle only, and there is no output during negative half cycle. For the next positive half cycle, again we are getting positive half cycle, and during next negative half cycle we are not getting the output. So this is like a rectifier. This is like a half-wave rectifier. During positive we are getting positive half cycle, negative we are not getting any output. Output is 0. So this type of circuit is half-wave rectifier. And here we are considering the operational amplifier. So if even the input is small, even if the input is small value, the operational amplifier amplifies the input, and which is applied the input of the diode. So there is no voltage drop of 0.7 in this case. Since input is small, we are getting the amplified version of the input at the anode of the diode, and that's why there is no voltage drop of 0.7, and this type of amplifier is called as the precision half-wave rectifier. In this case, the circuit type is precision half-wave rectifier, and this is the solution of this problem. Thank you.